Now let's look at the standard form of equation of a sphere. Now here, in terms of vector notations, in terms of vectors, the standard form of equation is r square plus 2r dot a plus d equal to 0. Okay, this is the vector equation of the standard form of equation of a sphere. Now let's see, let's prove whether this is true or not. We know the equation of the sphere. Equation of the sphere is what? R minus a, right? So r minus a dot r minus a equal to r square. So we need to have some kind of a perfect square. So let's convert this into a perfect square. So r square plus 2r a square. If we do this, then this becomes a perfect square. Plus d is equal to, now since we have added a square on the left hand side, we have to do the same on the right hand side as well. And let's take d to the other side. This is square. So this becomes what? This becomes r plus a square is equal to a square minus d. The equation of the sphere contains minus. So we have to convert this plus into minus. So how do we do that? Very easy. So make it a minus. So in which case the vector becomes minus is equal to a square minus d. Now this, let's write it like this. We do require and on the right hand side it is r square. So we have to convert this, the whole thing, into a square. So if we make this square, then we are doing big change. We don't want the quantity itself to change. So let's put it under a square root as well. Okay. So on the left hand side, we didn't really make any changes. Instead of writing plus, we have written it as minus times minus. Here we have squared it and square rooted it. So again, we have not made any change. Okay. So now, if you compare it with the equation of the sphere, if you compare these two, what do you notice? You notice that the center of the sphere is going to be minus a. And the radius would be square root of a square minus d. So this is the standard form of the sphere. We have shown that this is equivalent to this. So r square plus 2ra plus d equal to 0 is the vector form of standard equation. Now let's look at the Cartesian form. Pretty straightforward. Just take r, a and convert it into Cartesian form. So a is equal to, let's say, ui plus vj plus wk, and r is equal to xi plus yj plus zk. So our vector form is what? R square plus 2ra plus d equal to 0. So if we do the substitutions, xi plus yj plus zk square plus 2 times xi plus yj plus zk dot ui plus vj plus wk plus d equal to 0. So now when we simplify it, this becomes x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. The center would be what? Center C would be minus u minus v minus w. And radius would be what? Radius would be square root of a square minus d, which is nothing but u square plus v square plus w square minus d. So this is the standard form of the equation in Cartesian form. Now here again, coefficients of x, y and z are 1. So we can introduce these coefficients and say, let's say if they have ax square plus ay square plus az square plus 2ux plus 2vy plus 2wz plus d equal to 0. This is the general form. If you want to convert it into the standard form, just divide everything by a. So x square plus y square plus z square plus 2ux by a plus 2vy by a plus 2wz by a plus d by a equal to 0. So that is the standard form of equation of a sphere. That's it. Bye for now.